9 more days after today.
9 more days.
Right? So, one of you asked about tests. We're going to have one more assessment, and then we'll review for the final. It's going to be Wednesday.
Next Wednesday? Okay.
The Wednesday after.
We already have schedules for exams up. It's gonna like systems together.
All right.
I'm sorry, is this next Wednesday or next
Next
Wednesday?
Wednesday.
Okay.
May 16th.
Oh, we have an in-class test event then. I have an in-class test event.
Yeah. All right, we are recording, so we're going to get started. So today we're going to be discussing how quadratics can be graphed more efficiently than just doing a table of values. The table of values is not super efficient because if you don't have the right x values, you're not going to see the U shape. Let's say I gave you x values of like -3, -1, and -2. You're not going to see the curve of it at all. You might not even realize that it's a parabola. So just to remind you, if you're going to graph a quadratic equation, that's if you have degree 2 is the highest, it's going to be a parabola. Parabolas are U-shaped, and they're either upward, in this case, or downward like we had for Angry Birds. Angry Birds was a bunch of downward parabolas. And I want to show you all the connections between the graph of the parabola and the equation for the parabola. And I'm going to discuss that in terms of the intercepts of the parabola. So let's look at the x-intercepts of the parabola. If I am at an x-intercept, here is where the graph crosses the x-axis. What is this first point on the left? What are the coordinates, DJ? -3, 0. And then DJ, what's the other one? 2, 0. So I'll have you just notice that if you are at an x-intercept, then y has to equal 0. Because if you're touching the x-axis, like here and here, that means you aren't up or down any amount of y. You are at y equals 0. So to find the x-intercepts, you set y equal to 0 in your equation. So I'm going to write 0 equals x squared plus x minus 6. And I have to solve that equation. How would I solve it? Yeah. So that's why we did the last lesson when we did it, because you need to know how to solve a quadratic in order to find the x-intercept. So I'm going to snowflake it. What do I put at the top? At the bottom? 1. And what two numbers multiply to give you -6 and add up to 1? Yep.
3 and -2.
3 and -2. So here are my coefficients. So I get 0 equals x plus 3 times x minus 2. So therefore, my x-intercepts are at -3 and 2. So the x-intercepts are where the graph crosses the x-axis, and the way you find them is by factoring. And if you can't factor, you can use the quadratic formula, or you can use completing the square. You did get those tests back already. And pat myself on the back. I got it done by the end of the day yesterday. All right. This graph also has a y-intercept. The y-intercept occurs what's the coordinates of that point, Amelia? 0, -6. So notice, if you're at the y-intercept, the y value, the x value is 0. So if you are at an intercept, the opposite letter is going to be 0. So if I plug in 0 for x, watch what happens. It's y equals 0 squared plus 0 minus 6. Simplifying that, I get that my y-intercept is negative 6. So one thing that is useful in graphing parabolas is knowing the intercepts, the x-intercepts, and for a lot of them, there'll be 2 x-intercepts, and the y-intercept, which there'll only be 1 of. The other very useful piece of information with any parabola is what is called the vertex. I'm going to note the vertex here in green. The vertex is where the parabola comes to its lowermost point. I don't know why I'm pointing to my elbow. I'll point to the actual parabola. So that is the vertex. And so if you're looking at an upward parabola, it's going to be at the bottom. If you're looking for a downward parabola, it's going to be at the top. So the vertex is where the parabola changes direction. So if you consider like a little ant kind of sliding on this, is where the ant is going to change from going downhill to going uphill. That's the vertex. And one thing I'd like you to notice is that the vertex is exactly halfway between the 2 x-intercepts. So we have 1 x-intercept at -3, 1 x-intercept at 2. What x point is halfway in between -3 and 2? Exactly halfway. Brendan?
-1, 0, no.
-1?
Yeah.
So here is, I think, -1. Does that look to be halfway?
No.
You're close, though. Isaac? Yeah, it's -1/2. So the x value of the vertex is -1/2 because it's halfway in between both of those x-intercepts. Yes?
So for, so like I know it's different for each parabola, but for this one, like, why would it be the y?
Sometimes it is, but it wouldn't be because if it was, the x-intercepts would have to be equal distances from 0.
Okay.
In other words, one would have to be at -3, one would have to be +3. Or one would have to be 2 and one would have to be -2. But in this case, it's off. So that's the y, or the x value of our vertex, and to find the x value, sorry, that's the x value of our vertex. To find the y value, we would plug it into this equation over here. And I think it's going to be -6 1/4, I think.
Is that the formula that you use for
No, this is just for one parabola. So I'm just demonstrating it. So, as I said, the x-intercepts occur when y equals 0, here and here. The y-intercept occurs when x equals 0, and the vertex is halfway in between the 2 x-intercepts. Okay, so you just have to calculate that halfway point. And I tried to do some color coding here where the x-intercepts are in purple, the y-intercepts are in green, and then the vertex, I guess I didn't bother to put that on here. That's unfortunate. Let me do it. Here's your vertex. A little bit off of that y-intercept. Great. Questions on that? All right. So let's look at another parabola. We know it's going to be a parabola because the highest power is x squared. Let's find the x-intercepts and the y-intercepts and then graph it. So the x-intercepts occur when y equals 0. So to find the x-intercepts, I'm going to plug in 0 for y. Okay. I'm going to try and snowflake that out. Any ideas?
-5 and 2. Oh no, -2 and 5.
Okay, so we get x minus 2 and x plus 5 is 0. So our x-intercepts are 2 and negative 5. Any questions on that? So on my x-axis, I'm going to graph 2. There's 2 and negative 5. 1, 2, 3, 4, 5, negative 5. Now I'm going to graph my y-intercept, but first I have to find it. The y-intercept occurs when x is 0. So y equals 0 squared plus 3 times 0 minus 10. It's a lot easier to find the y-intercept because you don't have to solve anything. You just have to plug in 0 and a bunch of things go away. So the y-intercept, 0 plus 0 minus 10 is negative 10. Questions on that? So now on the y-axis, that's our vertical axis, I'm going to graph negative 10. Do we know the vertex of the parabola? In other words, the lowest it goes. Is this going to be the lowest it goes? Is this halfway between the two x and y? Okay. So what is halfway between the two x-intercepts? So you've seen x-intercept at 2, and you've seen x-intercept at negative 5. So what is halfway in between? Ashley? Negative 2 is here. And you can kind of visually look. I'm 3 away from this one, but this one I'm 4 away.
So
Here's negative 1. Negative 1 and 1/2. Okay? Negative 1 and 1/2 is halfway in between your 3.5 and then 3.5. So the vertex is somewhere, it's going to be lower, but that x value, bless you, is at x equals negative 1.5. Yes?
for the y-axis, can we just take the negative and the positive and that will be y-axis?
That will be. So what I want you guys to do is grab your calculators. This is why yesterday was good. Okay. Can you bring Charlie the tissue box, please? So what I'd like you to do is plug negative 1.5, in other words, negative 1 1/2 into the equation to find the y value. Do you remember what we did yesterday for the homework? We had to plug in x values and find the y. You're going to do that. This is the equation. And you're going to plug in negative 1 1/2 for x. So you can just type negative 1.5 for x. That was what was halfway in between, negative 1 1/2. So you have it. We're gonna let. Yeah, you didn't see. So it's negative 1.5 squared, because that's x squared, plus 3 times negative 1.5 minus 10.
Okay.
So Amelia, what was the y value?
I think I got it wrong. But I think I was like, okay, so negative 3.25.
No.
Because I got negative 16.75.
Negative 16.75?
That's what I got. Yeah.
Okay. So when you type it in, you need a parenthesis around the negative 1.5.
Oh, it's negative 5. I'm trying to get this. Oh, I got 2. It's negative 4.25.
Decimal, not 1.5, not 15.
I know, I put 1.5. I think it's negative 4.5.
Oh, yeah, okay, wait, okay.
Wait, what did you say? 12.25. Yeah.
That's what I got.
No, that's not. That's all it's
Oh, okay.
Because it says 16 and stuff.
Okay. This is how it should look in your calculator. If it doesn't look like that, you did it with something's wrong.
I need some water. I'm gonna die.
Okay, so then
Negative 12. No, young water next one.
It's not y'all water. I don't own the water.
Being's water is nasty. I'll just
All
die.
walk across.
Yeah, after that dehydration. I was like, okay. Good job.
I'm at negative 16. Yeah, did you put the first number first? That's what
Oh, wait, no, I
That's what I did. That's what happened.
All right, we're moving on. So, negative 1.5 comma negative 12.25. So I'm going to graph that. Negative 1.5 is right here, and I'm going to go down to negative 12.25, which is about right here, and then I'm going to connect the dots. The green point is my lowest point.
So do you still graph the line? So
Yep, has to go through all the points on it.
all of them?
If it doesn't, something is wrong.
That parabola looks kind of sad.
I think it's beautiful. Okay. Questions on how I found any of this?
No.
All right. So there are a lot of real-life applications to parabolas because they are directly related to what's called projectile motion. So projectile motion.
When I guys started in the video.
Hello? Does this sound like physics?
Yes.
Oh, that's good.
All right, let's focus. Projectile motion is what happens when anything or anyone goes in the air. It goes up and it comes down, and if you had a video of it and kind of had a trail on it, it would form a parabola, much like what happens in Angry Birds. So this references a pole vaulter, and there's an equation that represents the height given how much time it takes them to do their pole vault. So it's going to be negative 16t squared plus 28t gives the height in t seconds after leaving the ground. Here is the graph of, please calm down. Here is the graph of the pole vaulter as they go up and over, hopefully the thing that's there. Yes?
So is the T standing for the time?
It does.
So would it be like in between the 1.5 and the 2, or would it be 5 or like
So this represents the time going past, not the distance.
Oh.
Okay. All right, so let's take a look at the question. It says, given this function and its graph below, how long was the pole vaulter in the air? If the pole vaulter is no longer in the air, so at the end of their journey, what do you plug in where, knowing that you're looking for how long the pole vaulter is in the air?
Wait, no, actually, oh. Or wait, would you put in would you first find negative 16 and 28, or would you not do that because you're not like sure?
Yeah, you can't add those together on that.
So you wouldn't wait, then like where it lands between the 1.5 and the 2, that would be the time.
What would you say that would be, Amelia?
Maybe like 1.75.
Okay, so looking at the graph, Amelia's thinking it's 1.75 seconds.
I agree.
Because you've gone from being on the ground, which is where you start, to vaulting, and then coming down, and here you're on the ground again.
That's very fast.
Yes.
It's a very fast. So,
Okay. But you don't know this exactly. That's why they give you the equation. So if you are on the ground, what does h equal? So on the ground,
I got it.
yeah, I got H is 0. All right. So if you are on the ground, H is 0. So what I'm going to do is plug in 0 for the height. And in this example, it's actually going to be unnecessary to use the snowflake, nor do we need quadratic formula. What can I do to solve this?
Oh wait, never mind, there's two.
Like,
Wait a minute.
I think you need quadratic formula again?
It's unnecessary. It's not that you can't, it's just that you don't have to. So also that, I'm glad you came up with the one thing I didn't say, but you also don't have to do that.
Oh, simplifying that.
So what you're going to do is simplify by factoring out the greatest common factor.
So you just divide everything.
You factor out a 14.
So I get 47.
All right. So if a t or an x, whatever you're doing, occurs in all of the terms, notice there is a t squared and a t, you can always take that variable out. In this case, we could take out 4 times that variable because 16 and 28 are both multiples of 4. Now I'm going to set each factor equal to 0. And for the first one, 4t equals 0, so what must t be?
0.
And then this one, I get negative 4t equals negative 7, and t is going to be 7/4.
So is that the
Yeah, because
So
it's
it is so.
Yep. All right, I'm going to appreciate everyone focusing. All right. So let's take a look at what we did. We found that you are on the ground at 0 seconds and at 1 3/4 of a second. Does that make sense in terms of the graph and in terms of the situation?
Yes.
Yeah, so you start on the ground and you end on the ground. And this looked like 1.75 and it was 1.75, but we don't always know that that's the case.
So then would you put that into the formula?
No, because it just said how long, and how long was 1.75 seconds.
So and that.
Okay. And you know the height at that point is 0, so there's no reason to plug it in. Isabel?
Then why did you have to do to find out seconds? So you can-
Right. But what if it was 1.7 or 1.65? It's really tough to know unless you're sure you're exactly at 1.75, and you won't always be given a graph. So you have to have the alternate plan. But the graph is nice to check your reasoning, because if you have a prediction and then it comes out that way, it feels pretty good. Other questions? Yep.
Okay, so where's the, you see?
Right here?
No, that one.
Here?
Yeah, and then it went to that, so where did the negative 14?
The negative 4t go?
The negative 14.
So I divided both sides by negative 4. The negative 4's cancel, and negative 7 divided by negative 4 is positive 7/4.
Because there's two negatives on
Yeah, but nothing.
Oh, this one up here. So this one I set equal to 0. This is a factor. This one I set equal to 0. That's a factor. So because this times this equals 0, either 4t must be 0, in which case t is 0, or negative 4t plus 7 must equal 0. No, it's right here. And then I got 0 with it. So it's telling me that the pole vaulter was on the ground in the beginning at t equals 0 and after 1.75 seconds. So effectively what I was doing is finding the two x-intercepts right here and right there. Right? Other questions? All right, so this is another application problem that might pop up. We've dealt with rectangles a lot. So let's draw one just to get a sense of what's happening. We know the area is 120 square feet. And then we know its length is 2 feet greater than its width. How do we want to represent our sides if that's the case? Maggie?
Is it X and then X
Plus how much?
plus? Oh, wait, is it plus 2?
It is plus 2 because the length is 2 feet greater than the width. Any questions on that part of it? So in a test situation, you would get at least 2 points just for this information, okay? So never leave anything blank. So the area is the length times the width. So the length times the width is 120. There's a lot of ways to go wrong in solving this. Okay. What would we do to solve? DJ?
Distribute?
You would? Any ideas what to do next? Brendan?
Did the 120 on one side.
Yes. No, go ahead. Let's give it a shot. Let's try and factor. Let's see, 2 numbers at multi, ooh, I found it. Just thought of it. Brendan?
Would it be, 10, no.
Oh.
It's 10 and 12 better, it's going to be negative.
Okay, so you want the 2 to be positive, Brendan, so which one would it be?
Negative.
Good job. Nice job. So it's x minus 10 and x plus 12 equals 0. So x is going to be either 10 or negative 12. Which one of those makes sense in this context? Just the 10. You can't have a negative width. It says find the dimensions of the rectangle. So the width is going to be 10. What is the length? 12. So it's a 10 by 12 rectangle because the width is x units long, the length is x plus 2 units long. Is the area of a 10 by 12 rectangle 120? Yeah, and the length is 2 feet longer than the width. And this little symbol, which looks like half of a quote, means feet. Okay. Questions? All right, so we don't have a lot, but you do need to write down this formula for the last problem.